Good afternoon. Welcome to the QCIS channel. Where on this channel, you're going to get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and this afternoon, I'm going to talk about scales used for architecture and engineering drawings and standardized paper. Now, one must understand that it's very important that you understand scales because projects that are on paper are either going to be small projects or larger projects. Now, the three scales that I'm going to introduce to you are the architect scale, the engineer scale, and the metric scale. Each of these scales are all triangular and they function differently. Now, when we deal with the architect scale and the metric scale, the units are empirical. Basically, the architect scale uses inches to a foot on plans. When you deal with the metric scale, they talk about centimeters. Now, the engineer scale is basically used for larger projects, but the numbers on the engineer scale are not empirical. They're basically unitless. So what you can do with the engineer scale, if you are measuring a scale on the plans, is you can increase the scale or decrease the scale. Now, I'm going to show you all three scales so you'll know exactly what I'm talking about. Now, again, this scale right here, this is an architect scale. Again, it's got numbers that read from left to right and from right to left. And one thing you need to understand about the architect scale is that all of the numbers are, if you're going from left to right, the numbers double. But if you're going from right to left, the numbers are cut in half. So what I'm going to tell you is if I am reading a scale, I start from zero. That's where I start from. Everything starts from zero, even if I'm using a one scale. But just looking at the quarter scale, I start from zero. So that means every quarter of an inch is going to be a foot. Two, so I start at zero and I go to 4 feet. That's if the scale calls for 1/4 inch equals a foot. The same thing when I deal with what we call the one scale. I start right from zero and go, that's 1 foot. That means it's 1 to 1. Now, it's very significant that you understand this because when we deal with paper sizes, even though an 11 by 17 might call for 1/4 inch equals a foot, is that really true? No, because the paper is not 1 to 1. That's what you have to understand. But generally, the numbers here on the architect scale, they're all empirical. And what I mean by empirical, they have a unit associated with them, like an inch. Now, the architect scale, again, it's not very difficult to use. Now, I will tell you, if you're measuring some residential or some smaller type projects, this is the scale to use. Now, when we get into larger projects, let's say a road project, we get into this scale. This is called an engineer scale. Each of the numbers, you have numbers on the left and you have numbers on the right. Now, unlike the architect scale, the numbers on the left and the right are the same. Like up top, you have 10, and moving to the right, you have 10. Now, that indicates that for every inch, it equals 10 feet. So if I got 10 right here, again, I start from 0. Always start from 0. See it here. And with the engineer scale, you can see that the numbers are the same going from left to right and right to left. So at 0, if I was on a scale, 1 foot equals 10 feet, I know that this ruler, which is a foot long, but 1 inch equals 10 feet, multiply everything by 10. On a project, this would be 120 feet. And you can see the numbers are different. You have 40, you have 20, it goes all the way up to 60. Now, when it comes to an engineer scale, of course, I go back to the scale. It's also triangular. I can take a project. Let's say if the plans call for 1 inch equals 1,000 feet. Well, there's not 1,000 on this scale. But how could I make it 1,000? Well, I could go to any one of these scales. Most likely, I would use the 10 scale, the 20 scale, the 40 scale. Why? The 10 to 20 to 40 scale, and even the 50 scale, because it's much easier for me to come up with a whole number to get to 1,000 than if I were to use the 30 scale or the 60 scale. But the flexibility of this engineer scale allows you to measure large projects. And you're going to need to use this scale, especially if you're doing some roadway plans, because roadway plans have stationing. And your stationing starts from 0 plus 0, 0, and it could go as far as the project calls. So this scale on a large sheet of paper would be very advantageous. Again, on this 50 scale, you can see it. This 50 scale. It's the 50 scale. Well, to get the 1 inch equals 50 feet, start at 0. This is 4, and that is 50. So I can measure this paper. Measure this paper. And this paper, measuring it, I would get 50 feet, be 400 feet. Why? Because I have 8 inches, and 1 inch equals 50 feet. So 50 times 8 is 400 feet. That's if I was using this paper as a plan. That's the scale. Now, another scale that it's useful, but it's not as common in the United States unless you're doing metric projects. This is a metric scale. Here you have numbers like 1 to 20. Now, 1 to 20, and you also have a decimal, 0.05. Now, how do they come up with that 0.05? It's very simple. And the difference with this scale is you don't have numbers on the left or the right. They're alternating. Starts out here on the left and moves to the right, left, and right. But the way they get this decimal figure is when they take the 1 to 20, which is a proportion, or 1 divided by 20 to get the 0.05. But basically, you're going to utilize this scale the same way you use the engineer's or the architect scale. Now, share my screen and get to something that's very important too. Paper sizes. Now, again, all paper sizes are standard. Now, you must understand that because when you're printing plans, a full size of plans, it's going to be roughly 36 by 48 inches. Now, here's the standard US drawing sizes. Now, remember something. The architects and the engineers have different standard sizes. Now, when we're using a drawing size, an Arc A, it's 9 by 12. An Arc B is 12 by 18, and that's in inches. Now, also, if you're in Europe, you can use millimeters. And the largest sheet is 36 by 48, and these are all standard sizes. Remember, these are architectural sizes. Now, when we get into engineering, and that's standard by ANSI, the American National Standards Institute. That's what ANSI is. You might hear engineers say, okay, I need to put a plan on 8.5 by 11. This right here is an example of 8.5 by 11. 8.5 by 11 is a standard size paper. It could be a legal size. It's a letter size. Then if you want what we call a half set of plans, there's an 11 by 17. Now there's also some of these other standards that you don't see. There's 8.5 by 14, 11 by 14. But in the engineering world, we don't use that size paper. We use 8.5 by 11, 11 by 17, and then the next size up is 17 by 22. Then we get into 22 by 34. And then the largest size is 34 by 44. Now, these standards are set by ANSI. And you can see how the sets, how they line up. ANSI A, ANSI B, ANSI C, ANSI D, and ANSI E. Just like the architects. And these are all basic sizes. And when you set up your printer, you set up your printer to print the right size paper for plans. Now, again, I have a big set of plans in the back that are on 34 by 44. And when you're dealing with scales as well, this is where your paper means everything. Remember, if I have an architect scale and my legend calls for 1 inch or 1/2 inch equals a foot, well, now you have to think about that for a moment. What size paper am I actually going to get full scale? It's called full scale. And what you have to do is you have to look at the type of paper where you're going to get full scale. You're going to hear half scale, full scale, quarter scale. So basically 1:1 is what we call full scale. So the largest sheet of paper is going to get you your actual scale. But most of us in the field, we use a half size. So that means everything is going to be reduced in half. But again, all these sizes of paper, they're standard and they're set up by an organization. You have the architects and you have the ANSI. And it's important, again, that you set your printers up to print these standard sizes of paper. And in the engineering world and the architect world, we don't even call them printers. They're all plotted. And plotters, they cost a lot of money and they use up a lot of ink. Now, back in the days, they used to use different types of paper, real blueprinting paper. But today, everything's just used on a regular sheet of paper, and you have to know how to load your plotter. But again, what is the standard blueprint paper size. Well, again, blueprints and house plans will come in several standard sizes. Two of the most common architectural drawing sizes are 18 by 24, 24 by 36. You can also find them in 30 by 42, and these are all inches, 36 by 48 sizes. Now, large sizes are necessary on bigger and more expensive properties, but regardless of the blueprint paper size being used, its purpose is to show a trained person how to build that particular home. Again, I have supplied you with the paper sizes, and if you need them again, here are the standard paper sizes for your architectural drawing sizes and for your engineering drawing sizes. Again, I will keep this link and I will put it on the bottom of my comment section. Now, some other questions. What is the standard size for drawing plans? Again, depends on your construction drawing plans. Again, what is the standard size for construction plans? Well, construction plans, again, come in different formats as well. 18 by 24, 24 by 36. You hear that more often because they're more common. But again, you can find those plans 30 by 42, 36 by 48. Now, I'm reading those numbers out. They are empirical. These are empirical numbers. They're in inches. Now, when I'm talking about construction plans, I'm talking about exterior elevations, floor plans, building sections and details, general notes, and of course, a roof plan. Now, they'll also have a map of an electrical layout as well as any suggested fixtures and other elements. But again, I'm just giving you this information. Use it as reference material. Another question is, what is a full-size drawing? Now, again, architectural drawings, just like engineering drawings, they come in different sizes. But another question, what are the dimensions for D-size paper? Well, it depends on what you mean by D-size paper. Do you mean the ARC D or the ANSI D? Basically, the ARC D, you can look on a table, is 24 by 36 inches, and the ANSI D is 22 by 34 inches. And again, what I'm giving you, and this is by Engineer Supply, these are all the standard paper sizes. Very important that you understand the scales that I talked about and the paper sizes that I talked about, because you will be using these scales in drafting courses. Now, one thing I wish they would do is teach more basic drafting where we get into scaling. I know a lot of us are using CAD now. CAD's been out for the last 30-something years, but it's very important that you understand how the scales work and how to plot paper. Might sound insignificant right now, but in order to fit all of the correct information on the paper that's required for the plans, you have to set up your plotter right. That means most of the plotters are set up on a network, and you can print it from your computer, but you have to go in there and you have to set it up right. I've made mistakes myself when I've tried to set up paper that I meant to print it out on a 22 by 34, but I printed it out on an 11 by 17. I was wondering why my paper was very small. It's because I didn't set it up right. Again, when it comes to using these scales, just use them correctly, because they're going to help you in your career. Now, let me bring up something else. So go back. And I'm going to share my screen again. And I'm going to make sure I turn right back on so I can share the sound here. Just want you to get an idea of how it is to use an engineer and an architect scale. This gentleman is going to supply it for you. This is the engineer and architect scale, hand drafting 101. Check out the video.
Hi everyone, welcome to Draftscapes. I'm Chris Tuccio. In this episode, I'm going to show you how to use an architect scale and an engineer scale to draft measured drawings for your landscape design plans. Stick around. Hi everyone, welcome back. So if you're at all serious about becoming a landscape designer, landscape architect, or garden designer, at some point you're going to want to learn how to draw in scale. There are essentially two types of scales, architect scales and engineer scales. Now, architect scales are really good for doing small sites or residential properties where you want a lot of detail, and engineer scales are really good for larger sites like landscape architects typically work on, where you want a larger macro look at the environment that you're designing. We're going to look at both in detail today. So if you grab your different scales, let's throw it up in the air and let's get started. Okay everyone, so I will put a link in the description for the different scales that I'm using, but you should basically feel free or comfortable to get any scale that's designated as an architect's or an engineer's scale. I'm using an architect's to start. We're going to start with architectural scale. Most professional ones will come in this sort of triangular format that you see here. Okay, and so each of the three sides that you see actually has two edges on it with two different scales. So you'll get three sides, each side has a scale, and then the scales also run.
And what he's showing you is what the architect scale looks like. It looks just like mine. It's got three sides, it's got numbers on the left and numbers on the right. Let's continue.
From left to right, and then also from right to left. And the scales are indicated with these little notations here. So here you can see it says 1/4 of an inch, and on the left it says 1/8 of an inch. So the 1/8 inch scale runs left to right, the 1/4 inch scale runs right to left. If I flip it around to the other edge, you'll see that you have a 1 inch scale. So this is just the standard 1 inch equals 1 foot. And then on the other side, you'll see it's a 1/2 inch. And that runs right to left. So an architect scale actually has 12 total scales on it. Okay, so if we just take a second and we look, okay, if I take just a basic ruler, and this is a little tape measure that I had in my little shop, and we measure it out, you can see that it equates exactly. 1/2 inch equals 1/2 inch to a standard ruler. So this.
And that's an excellent idea that he is presenting. If you want to prove that 1/4 inch equals a foot, take a ruler and measure out your architect, your engineer scale, and your metric scale. I guarantee you will come out a foot. These are all standard. Again, when we deal with the architect scale, there's inches, so that means everything is imperial. Where when we get into the metric, that's empirical as well. But the engineering scale, it's unitless, so it's not empirical. Let's continue.
This is based in imperial units, so there's no conversion here, there's no changing the scale is what it is. And these are primarily used for smaller scale sites, residential properties where we want a fair amount of detail. So if I'm using this, and let's say that I'm going to be using my 1/2 inch scale, so if I just try and focus it a little better, if I'm using my 1/2 inch scale, I'm going to start from that 0 right here, and I'm going to work right to left. So I'll lay it on my drawing. Let's say that I want a line or some sort of edge to be 4 feet wide, okay, or 4 feet long, and in half-inch scale. I'm going to use my scale. Here's the half-inch, so I'm at the right point. I start at the 0, and then I'll simply hold, and then I'll draw from the 0 to the 4. Okay, and that's indicating that that line is 4 feet. Okay. Now, let's say that I was using a different scale, and let's say I had this line as existing. So this was an existing line with the 2 edges that you see there. But let's say that instead I was at a quarter-inch scale. So I'll flip to the quarter-inch scale really quickly. Okay, and if I wanted to measure this with the quarter-inch scale, I'd simply line up the 0 with the end of the line, and then I'd measure, okay, 0, that's the quarter-inch scale right there, 0, 1, 2, 3, 4, 5, 6, 7, 8. And so I know this line at quarter-inch scale is 8 feet. So with the architect scale, I can use any particular scale within the inch format that I want. And then I can also draw lines as well as measure lines to a particular dimension. So the scale works really well. It's very easy to utilize, and it's very handy. Okay, so that's a simple architect scale. Now let's move on to the engineer's scale. Okay, so next let's take a look at our engineer scale. The engineer scale is made in the same fashion as the architect scale, but it has different numbers on it. You'll see the numbers 10, 20, 30, 40, all the way up to 60 along the left-hand side. Now, these are actually unitless numbers, meaning that they're just numbers. They don't actually mean anything unless the designer specifies what they actually mean. And with this, so let's say we're looking at the 10 scale now, I could say, okay, this is at 10 scale, meaning that 1 inch.
Generally, what he's going to say is you can actually change the scale to scales that aren't even on this scale. Like I could change this 10 scale to 1,000 scale, which I'm just multiplying everything by 100. Or I could change the 10 scale to a 100 scale. And that's very significant because the numbers, they are unitless. So basically, this scale, as I mentioned before, is used for large-scale projects. Let's continue.
Equals 10 feet. And if I'm at 10 scale, you'll see 0, 1, 2, 3, those numbers from left to right. If I take my little tape measure again, you'll notice that the 1 inch lines up perfectly with the 1 of the scale. So what that's saying is 1 actual inch equals that 10 feet. So 1 inch equals 10 feet. So the actual scale does a lot of the work for you. If I'm in 20 scale, so let me flip it around. If I'm in 20 scale, here this indicates, okay, 1 to 20 scale, that 1 inch equals 20 feet. So now you'll see if I get my tape measure out again, okay, that 1 inch is equal to the 0 to 2, meaning that's equal to 20, okay? And you can imagine, okay, so now if I go to my 30 or 40 scale, let's go to 40 scale. I'll just flip it over like this. The 40 scale means that 1 inch equals 40 feet. And so you're going to imagine, you could see, okay, I'm going to guess that 1 inch is going to go to the 4, 0 to 4. And if I get my little handy ruler out again, you'll see that it matches up perfectly. So what this allows you to do, the engineer scale, I just shook the table a little, what this allows you to do is to not have to actually calculate anything in your mind. If I'm at 40 scale, let's say, that means that 1 inch equals 40 feet. So I can actually measure, okay, 0, 20, 40, 60, 80, 100. I don't have to do any calculations in my head. It's all laid out on the scale already for me, which is a nice feature of the engineer scale. Another really great feature of the engineer scale, I'm going to go back to the 10 scale here, is that the numbers, because they're unitless, they're not linked up to any sort of imperial format. So with the architect scale, we had quarter inch, half inch, 1 inch. Those were hooked up to a particular calibration of the imperial units. We had to be at half inch. We couldn't go anything other than half inch at half inch scale. Here, we have the option to actually actually increase by a multiple of 10 our scale by using the same scale. So if I was to say, okay, I don't want to be at 10 scale, I want to be at 100 scale, where 1 inch equals 100 feet. I could still use the 100 scale.
Let me give you a better insight. Okay, he's at the 10 scale. Because the numbers are unitless, if you look at the 10 scale, you have graduations in between 0 and 1. So to make it easy by putting it into layman's terms, there are 10 graduations per inch on the 10 scale. And if you don't believe me, start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where you get the 10 scale. And the same thing would be an indicator on a 20, the 30, the 40, the 50, and the 60 scale. But nonetheless, an inch is going to be dictated by the scale. 1 inch equals 30 feet. We're on the architecture. Everything is conclusive to 1 foot. 1/4 inch equals 1 foot. That's something that will help you with scaling. And it takes skill to scale. You want to get as accurate as you can with all of these scales. Let's continue.
In my head, calculate that I'm adding a 0 to each one. So this would now no longer, if I'm at 100 scale, so 1 inch equals 100, that means here that the 0 to 1 would indicate 100, not 10. And I'd just be able to calculate that very quickly in my head. So this would be 0, 100, 200, 300, 400. If I even wanted to go, and you'd probably usually not do this, but if I wanted to go to 1,000, 1 inch equals 1,000. So 1 inch equals 1000. This 0 to 1 would equal 0 to 1,000, meaning 1 inch equals 1,000. And the same is true for the 20 scale, 30 scale, 40, all the way down to 60. So let's say that I'm on my 20 scale. We'll use 20 scale as an example. Okay? And I want to draw a line. I'm at 20 scale, so that means 1 inch equals 20 feet. And I wanted to draw a line that was...
And again, before continuing, he's on a 20 scale. Well, look at the graduations. Graduation is what we call tick marks. It's 20 graduations per inch. You have 5, 10, 15, 20. That's an easier way to understand the engineer's scale. Let's continue.
60 feet long, okay? Well, I have my 0 here. I count 10, 20, 30, 40, 50, 60, and then I pull my line from 60 to 0. Okay, now I have a line that's actually 60 feet long. So you can see using the engineer scale or the architect scales is quite simple, quite easy. Doesn't take that long to use. You can draw and measure lines with both. As you practice, you'll find preference with either one. For most landscape architects, you're going to see that you're going to be using mostly the for engineer scales, for larger plans, for landscape designers, for residential properties, you'll primarily use an architect scale probably, but they're very interchangeable. So do make sure that you get comfortable using both. Again, they're very valuable tools. Okay, so if you liked the video and you want to see more content like this, hit the subscribe button below, and also head over to draftscapes.com. We're going to see a number of other articles and resources for landscape design and landscape architecture. Okay, I'll see you at the next video.
Now again, he was doing landscape design. And landscape design, since you have other features like elevations. And elevations are done in contour lines. So, when you deal with contours, the further spread apart contours are, excuse me for that, the farther your contour lines are spread out, the less steep your slope is. And this is when you can use the engineer scale, because you can figure out elevations of new contours when you're plugging them into existing contours. So, landscape architecture, landscape design, and engineering, you can use those scales. Now, if you're going to be doing some residential design, building design, you're going to design a restaurant, then you're going to get into using the architect scale. Now, again, I have a preference for the scale where it's needed. Since I'm an engineer, I generally use the engineer scale. I like the engineer scale, from my opinion, since the numbers are unitless and they're not empirical like the architect scale. The scale to me is a little bit more flexible. And I generally, because I deal with more road projects, like the engineer scale because I can go a little bit further with the lengths. Now, on the other side, if I just want to do a house or a shed or a rest area or a restaurant, the architect scale is very good. Now, something else you need to know when it comes to scales. When we deal with metric, everything's in centimeters, millimeters, and meters, up to kilometers. You have to understand the units. When we deal with architects, you're going to have dimensions like 3 feet, 5 inches. Now, as an engineer, we use decimals of a foot. So when I measure something that's 3 feet, 7 inches, I don't call it 3 feet, 7 inches. I call it 3.58 feet, because everything that I use is in decimals of a foot. But again, just wanted to give you examples on the different paper sizes, because when you plot your plans, make sure you understand the paper sizes. You have your ARC for architectures, ARC A, B, C, D, and E, and you have your ANSI, the American National Standards Institute, A, B, C, and D, and of course, E. Understand that the paper sizes for both the architectural drawings and the engineering drawings are different, but they both have one thing: the sizes are common. And that concludes this topic on paper size, paper standard sizes, and scales for architectural and engineering drawings. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some social and political content and some news, you check out my main channel, the 411 Talk Zone Radio Show. Now, if you can't find the 411 Talk Zone Radio Show or the QCIS channel on YouTube, you can find both of those channels on my Twitter page. Now, since the QCIS channel is an educational channel, you can also find that channel on my LinkedIn page. Yes, when I finish recording the videos, I post them on Twitter and LinkedIn for the QCIS channel. Again, the 411 Talk Zone Radio Show and the QCIS channel, they're posted on Twitter. Again, whereas the QCIS channel, that's posted on LinkedIn. Once again, thank you for viewing this content of use of scales and standard paper sizes for architectural and engineering drawings right here on the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.